Hi, this is Mike Hendrickson from Software Architecture in New York. I'm here with Ike from TidalScale.
Yeah.
So TidalScale, interesting name. Can you tell me what you do?
Sure. Well, we appeal to two classes of customers. One is application developers, and one is people who want to optimize data centers. It might be cloud-based or on-premise, and we do that in a very unique way. The application developers have access to a virtual machine of a size that they define. So today, most software developers define their software in terms of the hardware that they have to run it on. With TidalScale, it's just the opposite. They define their virtual hardware of a size needed to run their software. And would you like to know how they do that?
Yes, so if I'm NASA and I'm running a massive software system, is TidalScale saying I need a massive architecture and software?
What TidalScale says is, if you're running a massive job, you create the virtual server that's large enough to run that job. And we do it in 5 minutes.
And so you can scale to any size, for any size project?
Pretty much any size, yeah. And the way we do, let me tell you how we do that, okay? What we do is, we take a bunch of commodity, inexpensive servers, we glue them together, and boot up a single virtual machine. On that virtual machine, we can run a standard operating system. It could be CentOS, could be Red Hat, Ubuntu, FreeBSD. We have Windows up and running in the lab. You run whatever you want, and because we can do that, you don't modify the operating system at all, and you don't modify the application at all. So it's 100% bit-for-bit compatible. Why? Because we look like hardware. The operating system doesn't know that it's running on a virtual machine, but it's a virtual machine like you've never seen. It could be 20 servers, 15 terabytes of memory, 400 cores. It's big.
So you're like virtual machines just in time?
We're virtual machines just in time, dynamically adaptive, automatically or manually. Okay?
VMs as a service.
It's a VM. It's not VMs, it's one VM.
AVM.
Yeah.
Interesting.
Yeah.
So every application, every organization, if I'm one enterprise and I want to spin up, one virtual machine.
One virtual machine. And you don't have to worry about distributing the data, you don't have to worry about distributing the computation.
And you dynamically allocate the size that I need.
That's exactly right. We do this in a very unique way because what we want to do is keep all the processors and all the memory needed by those processors in the same place at the same time. That might change over time, but at any given instant of time, if we can put everything together that needs to be together, we have zero latency, we have zero overhead, and things run at machine speed. And so our job, using artificial intelligence techniques, is to make sure the processors and the memory are co-located.
So this sounds like a great tool for someone who wants to prototype a new part of their business, or scale and not know what size they need to scale to.
Exactly. That's exactly right. You build the size of the virtual server that you need at the time that you need it. And then if your data gets bigger or your business gets more complex or whatever it is, you just add more hardware servers, the machine gets bigger and you don't have to reboot.
And so, let's just take an instance of a retailer in December, and 2 days before the holiday Christmas season, and they're going crazy. Could they spin up a new?
Not only can they, they've done it. I mean, we are dealing with a company that builds an in-memory column store SQL database for big box retail stores. And that's exactly what they do.
So in a way, load balancing goes away with this sort of service because
take care of it.
And are you a service?
No, we sell this we're a software provider. We sell this hyperkernel software, and it runs on your hardware or cloud hardware, however you want to do it.
Or hybrid.
Or I suppose so. I don't have anybody doing that at the moment, but I don't see why not.
Okay, interesting.
Okay, yeah.
So where do you see this going if we have a conversation next year here in New York, where you come back home again? What would you like to say you guys are doing differently next year at this time?
Well, first of all, one of my friends and mentors is a guy named Gordon Bell. I started working for Gordon in 1976 on what became the VAX. I just published a paper with Gordon last month. Gordon thinks all servers will be done this way in the future because it just makes a lot of sense, okay? why do you have to worry about all this allocation of processes and processors and memory and footprints when that's what the operating system does? So, we just see inroads. When I started the company, I didn't know where it was all going to end up, and I still don't know where it's all going to end up. But I've been surprised because we mobilize all the resources, the virtual resources. We can move processors, we can move memory, we can move storage buffers, we can move anything anywhere. That has a great effect on our reliability because people say, gee, when you build a large system like this, it's going to be unreliable. Couldn't be further from the truth. Because we can detect failing resources in the thing, we can evacuate processors, evacuate memory, replace them with other resources, other physical resources, without having to take the system down. So we have a beautiful reliability story. And we've worked very hard over the last year to make it all very, very easy to use. So you can build one of these virtual servers in 5 minutes. You don't have to put in a purchase order and a budget request and wait 6 months or 9 months for a budget allocation to build this huge server. But frankly, some of our customers can't run their applications any other way. Okay, so this big box store, for example, in the holiday season, they're spending a huge amount of money just at that time, just to stay in the game. Yep. And with us, it's just you just add another piece of hardware.
So you could be for both companies that are in their transformation, or disruptors who are trying to take over industries that want to grow but don't know how big and how quickly they're going to get there.
Yeah, and by the way, my talk here was about containers, okay? Well, containers work great. In fact, our entire QA system is running containers on top of TidalScale. So there's lots of DevOps opportunities, there's lots of database opportunities. I was the former chief scientist at SAP. Okay, so I was there when SAP HANA was being created, and I built all the hardware for SAP HANA while my day job was running research at SAP. But my hobby was building these large virtual machines to run HANA. And we do Oracle, we're up in the Oracle cloud, we're running SAP HANA, it's a lot larger opportunity than I ever expected when I started the company.
We certainly look forward to that conversation next year at this time and see where you guys have come.
Take care.
Thank you.